the second part of lesson 4.2. The first part I talked about the different properties, the associative property, the commutative property, and the distributive property. Now 4.2, when we actually go into solving questions, you're going to have to decide which one of those is going to make the problem easier to solve and then use it in the problem. So again, example 1 and try it. This is going to be at the very beginning of your 4.2 in your workbook if you want to work along and then take notes so you have something to reference when you're doing your own problems. If I'm not there, you can be filling these out. So the try it, example 1, it's in the video, so we can skip right to the try it. It says Nancy wrote the expression 3x minus 12 to represent the relationship in a table of values. Use properties of operations to write two equivalent expressions. Okay, so it leaves a blank here in the first one. So we need to decide what our blank is going to be here. Okay, now this is something that we didn't talk about. It's not one of the properties, but it's the reverse of one of the properties, I guess I would say. So if you can see that right here, this looks like distributing, okay, but this is the problem here. So we're actually going backwards in distributing, and this is where we find the greatest common factor of 3x and 12. We've done some of these in the bell ringers. So the first thing is to find the greatest common factors of the numbers. So obviously for this, it's 3. Okay, so they wrote that out here. So the greatest common factor is just 3 because 12 doesn't have an x. Okay, so you write that outside of your parentheses, and then what goes inside is what these two terms over here are divided by that greatest common factor. So 3x divided by 3 is going to leave you with just x. That's right here. 12 divided by 3 is going to give you 4. So that's what's going to go in this other blank over here. So that's one equivalent expression. 3 times the value x minus 4 is the same as 3x minus 12. Okay, another way to write this, if you look here, you can see that that 3x is now at the back. So we can use which commutative property to rewrite that equation. Okay, so if we took the 3x from the front and moved it to the back, that means we used the commutative property. We rearrange those two numbers and we still get the same equation. So we know that the negative 12 has to go out in front because it used to be in the back. Now the 3x is, so it has to go here. So negative 12 plus 3x is an equivalent expression to 3x minus 12. The 3x is still positive and the 12 is still negative, so they are still the same. So if we look down here in the convince me, it says what property can you use to write an equivalent expression for 5x minus 2? Okay, so here's one where we can distribute. So we're going to take that negative 5 and we're going to multiply it by x and then multiply it by negative 2. Let me get these notifications out of here. So we have negative 5 times x is negative 5x, and negative 5 times negative 2, or we can bring that subtraction sign down here and do negative 5 times 2, and that's going to be negative 10. But you can see, and we know that subtracting a negative, which is happening right here, is the same as adding, which would have been the same as negative 5 times negative 2. That would have given us that positive 10. Okay, so we can actually write two equivalent expressions just from distributing. So we can write this one as well. Okay, so there's two. We used the distributive property to write two equivalent expressions to negative 5 times the value x minus 2. So if I switch to another example here, I'm going to skip over, I think it has a video. Yeah, we're going to skip over that. Okay, this one says use properties of operations to write two expressions that are equivalent to 3/4 n plus 8 plus 1/3 z. Okay, so I'm not trying to solve anything. I'm just trying to write an equation that means the same thing. Okay, so when I look right away, I see parentheses. So I'm going to think distributive. Okay, but we can't use the distributive property because there is not a number right there. Okay, and yesterday in our bell ringers, I said that if there is no number there, it's just going to be a 1. Okay, so I can distribute that 1, sure, but it's really not going to change a whole lot of things. Let me go back to that other blank I have here. So if we distribute a 1, we have 3/4 n plus 8, because 1 times 8 is 8, plus 1/3 z. Let me put some spaces in here so it kind of breaks it up a little bit. Okay, so I guess that is one equivalent expression. That's probably not the one it was going for us to use, but we can do that. Okay, that is the same as this. We got rid of those parentheses, so it's different, but it is the same. Another way that we can do it is that the parentheses tell me that we can use the associative property. Okay, when we use the associative property, the numbers have to stay in the same order. So it still has to be 3 divided by 4n plus 8 plus 1/3 z. Okay, so they have to stay in the same order, but instead of being here, we can move them here. Right? That's the associative property. That when there are parentheses, we can put those parentheses around two other numbers as long as they're in the same order and get the same equation. That's when we did the 2 plus 3 in the parentheses plus 4 is the same as 2 plus, in parentheses, 3 plus 4. Okay, so we can rearrange those parentheses as long as the numbers are all still in the same order. Okay, so here are two expressions that are equivalent, that are the same as this one up here. Okay, so let's move on to example 3. Try not to make these videos too long, but this stuff kind of takes some explanation. So it says, which of the expressions below are equivalent to negative 2/3 x minus 2? Okay, so here are our 3 options down here. Okay, these are the 3 that we get to choose from. So we have something we need to think about is that this 2/3 x is negative, and this is also negative. So my first thing I'm going to do is look for a problem where they are still both negative. Okay, so I'm looking at this one here. So here is negative 2/3 x and negative 2. Okay, is adding a negative the same as subtracting? Okay, and we could do this if we pretended, I don't have my tools. Can I have my, nope, that's not what I want. I don't have my toolbar over here, so I can't draw it out. But if this was a 3, so negative 3x minus 2, or negative 3 minus 2 is 1, or negative 3 minus 2, is negative 5. And if we have negative 3 plus negative 2, that's also going to be negative 5. So we know that this one is equivalent because adding the opposite is the same as subtracting. Okay, then we go and look at this one here. So this 2 right here is positive. So I already know that it's not going to be equal because my 2 up here is negative. So that one is not equivalent. Then I'm going to look over here at this one, and I'm going to try to see what they did. Okay, so what they did is they broke up the 2/3 x. Because I can see 1/3 here, and I can see x. Okay, so what we need to try to figure out is if I move the parentheses, because there's nothing to distribute, we can distribute a 1, or if I move the parentheses, will this be the same? Okay, so if I remove the properties, if we distribute a 1, 1 times 1/3 x is 1/3 x, 1 times negative 2 is negative 2. Okay, so we can pretend those parentheses aren't there. So then we have an x and an x. Now I can combine like terms here. So this is 1 over 1x plus 1/3 x. So I can't add them. I need a common denominator, and it's going to be 3. So if we have negative 3 over 3x plus 1 over 3x, that's going to be 3 minus 1, or negative 3 plus 1 is negative 2/3 x. So this one is equivalent. Okay, we have, this is 3 over 3, negative 3 plus 1 is 2 over 3, and here's our negative 2. So that's why that one is equivalent as well. So this is explaining why they are the same, right? Subtract the additive inverse, that's what we said. Subtracting is the same as adding the negative. This one, we could use the commutative property, so we reorder them. So we have -2. This would have to be -2 for it to be the same, and it's not. So that one is not equivalent to. And the expression is not equivalent to this, right? This goes with this one here. The expression, this goes together here, right? Because this was equivalent. This is not, is what we said, and then this one is, because we used the associative property. They just moved the parentheses down and combined like terms. So what's number 3 here is try it. So it says write 2 expressions that are equivalent to what is there. Okay, so what is something we can do? Well, we can flip them around. That's going to be the easiest one, that commutative property. So we have -3/4 minus 5/4x. All right, that is equivalent. I just changed them around, changed the order of them, but I'm still going to get the same answer. Okay, the other way that I could do it is, can we distribute anything? Or can we put in parentheses? Okay, so what we're going to try to find out is we can't factor anything out of those. 5/4 and 3/4 do not have a common factor. I already rearranged them, so the other thing that I can do is that additive inverse. Subtracting is the same as adding the opposite. So I'm going to put -5/4x. Instead of subtracting, I'm going to add the opposite. I'm going to add -3/4. Okay, so those are 2 expressions that are the same. It was subtracting a positive, now we're adding a negative. So those are 2 that are equivalent expressions. So equivalent expressions are all about rearranging the order, moving the parentheses or getting rid of the parentheses, or adding the additive inverse.